Welcome! We have yet another example of a sun-diving comet being destroyed by the sun. The data I'm going to show you comes from 3 different instruments on 2 different spacecraft. The first 2 are coronagraph images from the LASCO instrument on SOHO, the C2, which is shown in orange, and the C3, which is shown in blue in these images. And in the center, the SDO HMI white light imager shows the solar disk as we would see it. This data stretches from the 2nd to the 5th of August 2016. First, let me orient you as what you're seeing in these images. As I said before, the white disk in the center is the solar disk as we see it in the sky. The dark circle around it is the C2 occulting disk, which blocks out the bright light from the sun so we can see the faint coronal features. So that is effectively an artificial total solar eclipse. The orange area around it is the inner corona as seen by the LASCO C2 field of view. And the blue area around that is the field of view of the LASCO C3 instrument. The dark line at the bottom left, which sometimes appears at the top right, is the occulting disk support arm for C3. And you can see some solar features here. These bright streaks are coronal streamers. These are magnetic structures that stretch out into interplanetary space. Now let's take a look at the event itself. This is a video of the comet's path approaching the sun. It comes in from the bottom right. Here you can see the comet coming in from the lower right. And initially it has a fairly well-defined nucleus and coma and a fairly short tail. But as it approaches the sun, the tail grows and grows and grows, and the nucleus and coma become less and less defined. You'll note that the comet does not survive its passage through the sun. It does not come out the other side. So either it must have impacted the sun or vaporized as it approached the sun into gas and dust. You will note that there is a coronal mass ejection off the east limb of the sun, that's the left-hand side, as the comet approaches. More on that later. Now let's take a closer look at what's going on by only using the high-resolution C2 field of view. First, you should note that the CME is well underway before the comet even comes into the C2 field of view. Here it comes. There's hardly any coma or nucleus visible now. It's just a long streak approaching the sun. And then eventually the tail just dissipates into a faint cloud. So what happened to the comet? Let's take another look at that video. Now let's take a look at the CME in more detail. So now we're just going to look off the east limb of the sun. Wasn't that absolutely beautiful? However, some people argue that comets cause CMEs. It looked like it in this case, but it turns out that is not so. The first problem with this theory is that the CME is appearing above the C2 occulting disk when the comet is at least 5 to 10 million kilometers away from the sun, far too far for the comet to be influencing such a large object as the sun. However, for the CME to be appearing above the C2 occulting disk, it means it must have left the sun much earlier, when the comet was yet further away. The second problem is that the comet is coming in from the west, and the CME is on the east, so it's actually at the furthest point away from the comet as it could possibly be. Some people seem to believe that comets have strong electrical or magnetic fields, despite evidence from spacecraft that have visited comets to the contrary. They argue that the magnetic influence or the electric influence of a comet could disrupt the Sun's magnetic field, thus causing coronal mass ejections. Well, let's take a look and see whether that theory holds any water in this case. If a comet's magnetic and electrical influence was large enough to create a flare or a coronal mass ejection, then it should also be large enough to disrupt those coronal streamers that I told you about before. And as you see, the comet's passage through the corona has no effect on those streamers whatsoever. Being very weak magnetic fields, they should have been disrupted completely. But they weren't, so we can reject that particular idea. So what did happen to the comet? The dust and ice and rocks in the comet were probably vaporized by the sun and dissipated in the solar wind. There may be some evidence to support this if you look at the coronagraph data above the northwest limb after the passage of the comet. You can see there's a general outflow of faint material after the comet has disappeared. This could be the remnants of the comet. Of course, it also could be a faint coronal mass ejection. We will never be able to tell. So in conclusion then, we saw a small comet burn up in the solar corona. It had no visible effect on the sun, and it certainly did not cause the CME we saw coming off the east limb. Bye for now.